Hey Sam, it looks like this is the problem that you're talking about right here, and I don't think that you've got a fundamental misunderstanding. I think what's going on is a matter of confusion about where positive and negative things are, and making sure that your reference levels are set correctly. So I think what you're talking about is if you set the ground as height 0, then that would mean up here the starting height is 1.2 meters. So this would be y initial and this would be y final. So in that circumstance, the equation that you would use would be y final equals y, 1/2 gt squared plus v initial yt plus y initial. Initial velocity is 0, and you would put in y final is 0, equals 1/2 9.8 times t squared plus y initial is 1.2 meters. Now, here's the thing. You can't just set where 0 initial and final height are. At your reference level, you also want to set what direction is positive. Okay, so we'll say up vertically is positive. And so if we do that, then that means gravity is negative. So we end up, when we're solving this, we get negative 1.2 equals 1/2 times negative 9.8 times t squared. Okay, so that means these negatives cancel and then we end up with a positive time of 0.49 seconds. Okay, there's another way that we can do this. I'm going to write this in green. So a common way also to do this, especially if your object is just moving downward, you can say where your object is starting is the reference level. And you can call that y initial equals 0. And down here, you can say this level is y final, right? And that's 1.2 meters. And we can call that a positive distance if we say down is positive. And this makes it really super convenient to say down is positive and where we're starting is our 0 position, because that's when you can use equations like this where y just represents vertical displacement and your gravity is always positive. The way that works out is if you use the full quadratic equation again, y final equals 1/2 gt squared plus v initial y times time plus y initial. That means y initials equals 0, v initial y times time is 0 because we're starting vertically from rest, and we end up with this. Okay, so if we say our starting position is initial position 0 and down is positive, then we can just use a simplified version of the equation where the vertical distance traveled is just 1.2 meters. And if down is positive, then gravity is 9.8 times t squared, and just everything's positive, so it's simpler. And we get t equals 0.49 seconds. So 2 ways of solving this problem, both get the same answer, but we're using either the starting position or the ending position as reference points. And we're being clear to define what direction we're saying is positive and making sure our acceleration is in line with that direction. Okay, hopefully that makes sense. Totally email me again if you have more questions.